Hello again. Welcome to Engineer's Mindset. So we are still on Gallilean Transformation equation. Let's consider the question on the board. It says a vehicle moving at 300 km per hour and conveying student passes a police officer standing on a platform at 00 hours. 60 minutes later, the officer observed that a dog running along the track in the same direction as the vehicle is 1,600 kilometers away. What are the coordinates of the dog as determined by the students in the vehicle? So, like I always say, in Gallilean transformation equation, we always have two reference frames. First is the reference frame of the observer, and the second reference frame is the reference frame where the event is actually taking place. So we have the first reference frame. Let's simply call this, okay, this the coordinate of the first reference frame. Call here Z, call here Y, call here X. So if you look through the question carefully, you observe that the question says 60 minutes later the officer observed that. So which means the officer is actually what? The observer. So this first reference frame is the reference frame of the officer, which in this case is the observer. So we have a second reference frame. Okay, we have a second reference frame. So we simply call here Z prime, simply call here Y prime, and simply call this distance X prime. Okay, now the question says a vehicle moving at 300 km per hour conveying students passes a police officer standing on the platform. So the vehicle is actually what? This is the second reference frame. The vehicle conveying the students is the second reference frame. Okay, so if we read through the question again, it says 60 minutes later, the officer observed that a dog running along the same track as the vehicle. So which means this is the vehicle and then we have a dog. So we'll simply use this to represent the dog. Please forgive me for this, but that is the dog. And of course, this is what the reference frame of the vehicle conveying the students. So this is the reference frame of the vehicle conveying the students, and this is the dog running along the same line as the vehicle conveying the students. Then an observer from which is the officer now spots an event, that event taking place about a dog, okay, running in the same direction as a vehicle. Now, the question is asking us, what are the coordinates as determined? What are the coordinates of the dogs as determined by the students in the vehicle? So simply, let's simply draw a line here which represents the coordinate axis of the dog. Okay, so let's simply draw a line here which represents the coordinates of the dog. Okay, so this is the origin of the observer, which is the officer. Distance travel from the observer to the dog itself is simply x. It remains x as can be seen here. Is simply x. So we'll call that x. Meanwhile, from the origin of the vehicle itself, which is now the second reference frame where this event is taking place, distance from the origin to the dog itself, we'll simply call that x prime. So call here x prime. Now the distance of the officer to the vehicle is moving with a certain velocity at a given time. So which means we can actually find this product Vt. That gives us the distance between the origin of the officer and the origin of the vehicle. I will simply say that total distance x from the officer to the dog taking place in this second reference frame is simply the sum of Vt and what x prime. It's as simple as this. So this is a diagram to represent the whole information that is given to us. Now next up, let's get out the parameters that was given to us. First of all, we are given that a vehicle moving at 300 km per hour. So which means this is the speed of the vehicle, and as such, we can actually find the velocity of the car. So speed V, okay, was given as 300 kilometer per hour. And of course, we need to convert this to what? Meters per second, which is the ground unit of velocity. So velocity is now equal to 300. Kilometer simply means by 10 to the power of 3 kilo. So simply multiply by 10 to the power of 3. Okay, so it becomes in meters all over hour. To obtain 1 hour is simply 60 by 60, which actually gives us 3,600 in seconds. So 1 hour in seconds is simply 60 by 60, and that's simply in what? Seconds. So we'll be able to convert the velocity to meters per second. And if we do this, we are going to simply observe that V is actually equal to, so 300 exponential, it becomes 300 by 10 to the power of 3 all over 3,600 seconds. Okay, in meters per second, all over 3,600 meters per second. So therefore, velocity V is now equal to, so we'll have V to be 83.3 meters per second. So this becomes the velocity of the car. Okay. So a vehicle moving at 300 km per hour and conveying students passes an officer standing on the platform at 00 hours. 60 minutes later, so the time is given as 60 minutes, time t, okay, t equals 60 minutes. And of course, we need to convert this to seconds simply by multiplying also by what? 60. 60 seconds actually makes a minute, and therefore 60 minutes will be 60 by 60 seconds. So we simply have this to be 60 by 60. So the time actually is 60 by 60, which is 3,600 seconds. Okay, so the time which this event is being experienced is actually at 3,600 seconds. Okay. So 60 minutes later, the officer observed that a dog running along the track in the same direction as the vehicle is 1,600 kilometers away. So which means the distance of the dog, as can be seen from the observer, is actually 1,600 kilometers. And remember, that distance is actually what? Horizontal in the x-axis. Always take note, the motion of a dog actually is purely horizontal in the x direction, not vertical and not in the z direction. So the distance as can be measured by the observer or the officer as can be measured from the dog is simply 1,600 kilometers in the x-axis. So we simply represent that here. Distance x, okay, is simply equal to 1,600 kilometers. So always we convert to ground unit. That's simply 1,600. Kilo is by 10 to the power of 3 in meters. So this becomes distance x. So this distance measured from the observer to the dog is actually 1,600 by 10 to the power of 3 in meters. That's the distance as measured from the observer towards the dog. Okay, we simply have that. So all we need to do now is find what? V times time, and then find the coordinate. This is the coordinate of the vehicle, and this vehicle conveys the students. So that's the distance of the vehicle or the students in the vehicle as can be measured from what? The event taking place, which is the dog running along the same track. Okay, so let's get these coordinates now and see. So I simply said that the total distance from the observer to the dog, which is x, so we simply call that x is actually equal to the sum of velocity times time from the origin of the observer to the origin of the vehicle. So we simply have vt plus the distance from the origin of the vehicle, which is the coordinate of the student in the vehicle to what? The event taking place, which is the dog, that's x prime. So plus x prime, and therefore we can now make s prime subject, and that's simply x minus, by sending vt over here, it becomes x minus vt. So we need to now obtain what is vt since we already know the value of x. Vt simply means the velocity times time, product of velocity and time, and the velocity of the vehicle gave us, by conversion we had 83.3 in meters per second. The time is simply 3,600 in seconds. So we simply have 83.3 multiplied by 3,600 seconds. So that simply means that Vt is equal to, that simply gives us 300 by 10 to the power of 3 in meters. So this is Vt, and therefore x prime is now equal to, so we said x is the distance measured from the observer to the dog, which is 1,600 by 10 to the power of 3. So we simply have 1,600 by 10 to the power of 3 minus Vt, which is 300 by 10 to the power of 3. So this simply means that the coordinates of the dog as measured from the student in the vehicle is simply 1,300 by 10 to the power of 3 in meters. Now, I've said that since the coordinates of y and z for the observer is not given, it means that the position of the observer itself is x from the dog, and x is 1600, which is simply okay, x, y, and z, and t. So this is the position of the officer. And of course, if we draw this x, if we put this down now, x is simply 1600 in meters by 10 to the power of 3 in meters. Okay, y is unknown, so simply put y as 0. Z is also unknown, simply put z as 0. And then finally t, the time was given as simply 3600 seconds, so you can write that down here, 3600 seconds. So this is the coordinate of uh, the officer or the observer in the first reference frame. And the coordinates, of course, in the second reference frame of this event taking place, we simply call that x prime, y prime, z prime, and t prime. So I said in the introductory video that since motion is not in the y-axis and also not in the z-axis, then y prime is still the same thing as y, z prime is still the same thing as z, and of course t prime remains the same value as t. So that simply means here now, since we're writing x prime, y prime equals y, z prime equals z, and t prime equals t. So therefore, the coordinate of the students now becomes, as measured from the dog, is now simply equal to x prime, and x prime gave us 1300 by 10 to the power of 3 in meters. So x prime, y prime is 0, y prime is equal to y, and that's 0 there. Z prime is also equal to z, which is also 0 here. And then finally, we say t prime equals t, and t here is 3600 seconds. So you have this to be 3600 seconds. So these are the coordinates of the students in the vehicle as measured with respect to the event taking place along their track. So you simply have this x prime, y prime, z prime, and t prime. All right, guys. So I hope you find this video very interesting and helpful. Please, if you do, I would like to get your thoughts in the comment section. And of course, if you're new to the channel, don't forget to hit the subscribe button to keep getting updates when content as this keep dropping. I will see you in the next video with more and more wonderful and tedious questions on Gallilean transformation equation. Till then, stay safe and cheers.